to fix something with the audio right now.
Okay.
But before you start, give us a sign and just wait for a little wave forward.
Oh, always. Right, I'll always signal to you before. Cool. Check. Cool. Just before we get started, I did hear some cell phones or tablets or something like that making some noises in the audience just before. If you could please make sure that your noise-making devices are switched off before the talks start, that will save us a lot of embarrassment during the sessions and save us from any interruptions. So please mute your devices if you have any that are currently not muted. And do check them because you probably have forgotten. So you're ready? AV people, you ready? Fantastic. Okay, so it's the start of the last block of talks here at PyCon 2013. Who here is slightly disappointed by that? So am I. But the good news is that we have 3 fantastic talks to finish off the day. Starting off with Luciano Ramalho, who is going to be presenting iterators and generators the Python way. Please make him welcome.
Again, thank you all for being here. I just want to let you know that in Brazil, where I live, we're going to have a couple of excellent conferences co-located in October. The 9th edition of the Brazilian Python Conference and the Worldwide Clone Conference will be held in Brazil. It's the first time that it goes across the equator, so we are very proud to have been selected to host that conference as well. And after those conferences, we are going to have an excellent sprint in João Pessoa. It's called the Caipirinha Sprint. It's already a tradition, and please check it out. And I will hope to see many of you there. So let's start. One of the things that really calls one's attention when you start studying Python is how elegant the for loop is, right? And why is it so much better than that one? Mainly because in that one there's no abstraction for iteration. You're just actually this is the for statement in C and in many languages that imitate it is just a way of executing some expressions in a certain order. And then you have to have this I variable, and you have to manage it and do all these things, but you're not interested at all in the value of I. You're just using it to indirectly access the thing that you are interested in. And Python is better because it allows you to focus on what you're interested in, right? So Java initially followed the same for statement, but then in 2004 they introduced this one, which they call the enhanced for in the documentation, and everybody calls the for each, right? So this has been available in Java since 2004, and this in Python since 91. Okay, you can iterate over lots of things in Python, not only native objects or built-in objects, but also arbitrary things like, for instance, a Django query set or anything that you implement using a couple of interfaces that I'm going to show you. Okay, so let me give you a brief example. These are like snapshots from a session using Django, using the Django shell. So what I'm showing here is Django has this debug object called connection, and through it you can actually read a log of the last queries that Django has sent to the database. Okay, and just to be short, I just assigned the connection queries object to the Q variable, and you can see that it's empty. But then what I do, I import a model from a model file, And then when I do this, which is, trying to build a query set with, this would fetch all the objects of the municipal model, which represents municipalities in Brazil, and there are 6,500 of them. But I only want to have the 5 first ones displayed. So an interesting thing is that after you do that, you notice that there was no database access at this point. So this result here is some kind of weird object that is not really the data from the database. So what is it? This is what I'm going to show you. It's something that you can iterate over. And when you iterate, then when you check the queue, you will see that the query was made. So this is what we call a lazy iterable. It's something that is iterable, but it produces results lazily, only when needed. So what is an iterable? Here's an informal recursive definition. Iterable is something that is fit to be iterated, just like edible is something that is fit to be eaten. Okay? Now, the for statement is not only used it's not the only construct in Python that handles iterables. There are lots of things in the language that support iterables. For instance, list comprehensions, which are an excellent feature, they basically consume iterables. See, the S here can be any iterable, and it produces a list of the items in that iterable, probably changed in some way or operated on. So here I have the letters, but then I get the code from the letters, right? So this is what a list comprehension does, and the point here is that the list comprehension can consume any iterable object. More recently, we have now set and dict comprehensions, which follow kind of that same syntax, but just with different delimiters and different internal syntax, that also build sets and dictionaries from arbitrary iterables. Okay? And there are many iterable types that are built in the language, from the string variety to dicts and files, sets and frozen sets, list, tuples, X-range, right? There are also many built-in functions that take iterable arguments. And some of them are really useful, but underused, like for instance sum. Sum just takes any iterable that generates numbers and returns the sum of them. Okay? And it does it in a very efficient manner by iterating. So if you give it something that is lazy, you can actually sum like 1 billion numbers with that. And zip, by the way, is another interesting thing. I won't be able to show you. I just want to give a hint that zip is unrelated to compression. What zip does is it takes 2 iterables and returns like a merger of them, just like the zipper works. Look it up later. I don't have time to show this. I'm just sparking your curiosity here. Another example of iterable support in Python is it's built in the syntax, actually. There's operation called tuple unpacking, and this is also called parallel assignment. When you assign to multiple variables on the left-hand side, what you need to have on the other side is something that is iterable. Any iterable will do. But this iterable must generate exactly the precise quantity of items. Otherwise, Python will throw an error. Okay? So here's another example. And you can actually do this implicitly in the for loop. See? Here in my for loop, I have 2 variables. And this makes for a very readable code in Python. Another example of syntactic support is that, for instance, I have this function here that allows you to calculate the length of the hypotenuse of a triangle. And I can call it giving 2 arguments. But if I have a tuple of sides, I can't call it directly like that. But if I put the star in front, then it works. Because what it does is going to iterate over whatever iterable is after the star, and provide the positional arguments in order to the function. So this is also very elegant. So now let's go to a better definition of what an iterable is. A Python iterable is an object for which the iter function, from which the iter function can produce an iterator. So there is this mysterious iter function that we seldom use directly, but that is internally used by the for loop, for instance, and all those other operations that handle iterables use it. So when I do iter over x, Python does one of two things. First, it invokes a dunder iter method of the x object to try and obtain an iterator, okay? But if that doesn't exist, then it does something else that's really interesting. Then Python builds for you an iterator automatically that will just assume that it can fetch the items of the x object by going over indexes from 0. Okay? So let me give you an example with code. So suppose I want to model a train. Okay? So a train is a collection of cars, and train 0 is the first car. Okay? So how would this be used? I can instantiate a train, I can ask for the length of the train, I can access individually the different cars, okay? And I can iterate over it, okay? So how do you implement this? It's very easy. For the iteration part, the only thing that you need to implement is the dunder get item. Okay? So dunder get item is actually the method that is called when you do this. And in this case, I just synthesized this string that says car number 1, car number 2, and so on and so forth. So this is all you need. For an object to be iterable in Python, the simplest thing you can do is you can implement dunder get item. Okay? And this is called the sequence protocol. Okay? The whole sequence protocol is not only implemented with dunder get item, you also need to implement dunder len, because sequences have a fixed length. But if you implement those two things, you can do those operations. Okay? Now, a protocol is a synonym for interface that is used in dynamic languages like Smalltalk, Python, and Ruby. And the difference from an interface in Java, for instance, is that a protocol is not declared and is not enforced by static checks in the language. But overall, it's the same idea, the idea that you implement a set of methods that allow some kind of operations to be done in the object. Okay? Now, more recently, Python has added support for abstract base classes. Raymond Hettinger gave a great talk about this yesterday. And here's a little UML of 4 of the abstract base classes, or ABCs, that are defined in the collections module. So we have the container, the size, the iterable, and the sequence. Okay? And in UML, you know that italicized names mean abstract classes or abstract methods, right? So there are 2 ways of implementing it. I'm just going to switch back and forth from these slides here. So you can see the original implementation was this, and this was an informal implementation of the interface or of the protocol. And now if I want to implement it as an interface, using the interface, what I do is I import collections. See, the rest of the code doesn't change, see? The only thing that changes is that I import collections, and I now inherit from collections.sequence and not from object. Okay? So what do I gain by doing this? You are now being more explicit that you are implementing something that is going to behave like a sequence. And you just need to implement these 2 abstract methods like we did before, but you gain the functionality of these other 5 methods that are implemented in the sequence abstract class. Okay? So operations like in and reverse and reversed and so on are supported because I just inherited them. Okay, so there is also an iterable ABC. And the iterable ABC says that a concrete subclass of iterable must implement the dunder iter method, right? And the dunder iter method returns an iterator, which is an instance of this other thing here. And the iterator must implement a next method, which was renamed to dunder next in Python 3. It became more consistent. Overall, Python 3 is more consistent. Python 2 is already one of the most consistent languages that I know of, and now Python 3 is even better at that. Anyway, so the iterator interface, so then you have those two things. You have the iterable, and the iterable is the thing that produces an iterator. And the iterator is the thing that you iterate over. Okay? So this has to implement the next method. And because there are two spellings, and because of the way the Python API works, they've implemented a built-in function called next that you can call, so you don't need to worry about this difference. And it's more elegant to just call it next. That's what I'm going to do in the examples. So what is an iterator? Iterator is a classic design pattern, right? Described in this book. I prefer the description in the poster, the Head First Design Patterns poster. And what it says here is that the lady here is the client of some framework, and this framework has two kinds of things that internally are implemented very differently. But the only thing that she has to know is that if she instantiates an iterator, then she just needs to call next, and everything will work, right? So the iterator pattern provides a way to access the elements of an aggregate object sequentially without exposing their underlying representation. That's what it buys us. How do you implement the pattern as described in the book in Python? Like this. It's kind of complicated. You implement the dunder iter method, and the dunder iter method instantiates and returns an iterator. And the iterator does a lot of housekeeping to know what is the current item, whether the collection has ended, and so on and so forth. Okay? And it implements the dunder next method. Okay? So if you implement this will work, just like before. So now we're going to come back to that definition. So you have two ways of implementing an iterable in Python. You either implement the iterable interface that I've just shown, or the sequence protocol that I showed before. Now let's look at another example. In this case here, the C code is actually using the value of I. So then the value of I becomes relevant. So how do you do that in Python? Here's the wrong way to do it. But often people that come from those other languages do it like that. But it's ugly. 95% of the times when I see the range of the len of something, it's just wrong. It works, but it's ugly. Because you really don't need this I thing. You don't need to access the args like this. The way to do it in Python is like this. So you have this enumerate thing, this enumerate function. And it returns a tuple for each item in the argument. A tuple where the first position is an index and the second position is the item. So that's much more readable. You don't need to worry so much about boundary conditions and so on. Okay? So enumerate returns a lazy iterable object. Okay? And that object yields the tuple that I just described. So let's take a closer look at it. If you do E equals enumerate some string, and you look at E, then the console tells you that's an enumerate object. So what can you do with it? You can iterate over it. That's great. Usually you do that implicitly, right? But if you look closely at it, you will realize that it implements the iterator interface. So this thing I can call next, and it will yield these tuples in sequence. Until there are no more tuples to be generated, then it raises this stop iteration. Okay? So what is the difference between an iterator and a generator? by definition, if you look at the Gang of 4 book, the iterator retrieves successive items from an existing collection. That's all it does. This other collection must exist because that's part of the pattern. Okay? Now, but a generator is more generic in the sense that its only responsibility is to implement the iterator interface by implementing next, but it can just, return made-up items. It doesn't need to access a collection. Or it may access a collection and do something else with the items before returning them, which is what the enumerate does, right? So here's an example of how do you implement that in Python. There's this thing called a generator function. Any function that has the yield keyword in the body is compiled as a generator function. It becomes an object that is not a function. Okay? And when I invoke this, what I get is a generator object. See? And then I can iterate it over it or call next several times. This is kind of a funny example because there's no loop inside the generator function. Usually there is a loop. But this is interesting to show you that each yield will generate, or each time the body of the function goes over an yield, this will generate one of the items for the iteration. Okay? Here's a second example. In this example, the body of the function says print starting, then yields A, then says here comes B, and then yields B, and then prints the end. Okay? So notice that when I call the function, the generator function, the body is not executed, because if it was, we would see it starting here. So none of the body executes when the generator function is called initially. What you get is this generator object. Now, when I call next for the first time, then I see the body starting execution, and it goes to the first yield, yields the result, and freezes. Execution just freezes here. And then, when I call next G again, it says here comes B, and it freezes again here. But still, we have not fallen through. And when the execution falls through, then we get a stop iteration. So all of this is done by the generator function machinery for you. So how do you implement the train with the generator function? This is how. Okay? So I just loop over the amount of cars that I need to generate, and I use the cars. Now, if you compare this with the other implementation, that's a big win, right? I don't need this other function anymore. I save lots of lines of code. But the performance characteristics of both implementations are the same. Now, so this is so good that in the next iteration of the Python language, the core developers decided to introduce generator expressions. So generator expressions are just like these comprehensions, except that they use parentheses instead of brackets. And you can basically iterate over the results of one of them. But what it gives you really is a generator object, right? And so again, you have the same thing. So it's the same result that you get from calling a generator function. And again, I can implement the train with the same syntax, with this other syntax. And this is just a comparison of the two ways. When would I choose one over the other? Well, this is useful when you don't have some complicated algorithm to fetch the next item. If the implementation is too complicated, then it's better to use a generator function. Right? There are several built-in functions that return iterables, iterators, and generators. I talked about enumerate, reversed is another one that is also lazy. There is also a fantastic module called iterators, which has tons of functions that I won't be able to describe here. Just look them up to do amazing things with generators in a lazy way. So this is really an excellent toolkit for anybody that has to deal with very large data sets. Because whenever you're using generators, you're saving memory, right? And in Python 3, we now have a lot more things that produce generators. Many functions and methods of the standard library that used to return lists now return generators. For instance, the keys method in dictionaries now returns a generator that yields the key, so you can do it safely even in a dictionary that has 1 trillion items without needing to generate a list of 1 trillion keys. Okay, so and when you actually need a list from those functions, you just call the list constructor on the result. So it's easy and it's explicit that, no, really, I want 1 trillion things now. Okay, so just to finish, I'm going to show you a practical example. This is a script that I developed for work 3 years ago. And it was the first time that I used generators for, in anger, let's say. So, and what I did was I was doing this script to translate databases from a very old semi-structured database system that we used at this place to some more modern representation, basically to JSON, so that we could load on CouchDB or MongoDB or databases like that. And the code for this is here, okay? But I will show you the code. Can you read it? I guess not. So, no, the idea is here is just to show the structure, okay? So, the thing is, here we have a main loop around here. This is all reading the command line, and this main loop needs to write the JSON file, okay? And I have another loop. I will need another loop to read the data from the old format, right? So one way to do it would be to merge those two loops. Have a loop over the input that generates the output, okay? So the logic of reading and writing would be mixed up in the same for loop. This would be one way of doing it. And I actually implemented it like that at first, but then a necessity came that we needed to read another format. And then it was going to become kind of messy, having two different ways of reading and one way of writing interleaved in the same for loop. So the way I did it was I split the program basically in 4 parts. Okay, so there's the main part, the loop that writes, and 2 loops that read. So the main part, like I said, just reads the command line arguments, and this is the font is a little bit bigger. But the interesting part here is this part. Here you can see that depending on the file extension that I'm reading, I'm going to select one generator function here and the other here. Okay? So see, these two are generator functions, and what I do is, depending on the file format, depending on the file format, I will use this or that, okay? And I pass the function as an argument to the write_JSON_array function, okay? So the write_JSON_array doesn't care what it gets. It gets something called the iterators, and it just iterates over them, okay? Now, so one of the generator functions is implemented like this. This is the one that reads this format. And notice that it does some processing of the records, but basically builds a dictionary that represents just one record and yields it. Okay? And the other one, which reads the other format, does the same. It has a lot more work to do, but basically it builds a dictionary that contains a record. So this is an example. Now I have this way of integrating these two loops in a way that is memory efficient, right? Because another way of doing it would be just to read everything to memory using one function or the other and then write. But we had large data sets, so we couldn't do that. But implementing that with a generator's function allowed us to do it in a lazy way, so there's no limit to the size of the data set that I'm reading. Okay? So, what didn't we cover? Because we were talking about generators, right? So we didn't cover the idea of sending data into a generator function by using the send method, which you can use instead of next. And when you use the send method, then the yield becomes an expression. You can read the argument that was sent by send, okay? Now, the reason why I didn't show this, well, first, it wouldn't fit in half an hour, but most importantly, it is not, the send mechanism is not useful in the context of iteration. It's useful for pipelines and other kinds of constructs. Actually, when you use send, often you're using generator functions as coroutines. And David Beasley says that coroutines are not related to iteration. That's an easy mistake to make, okay? So, this is it. I don't know, I think we have like a minute.
Yeah, I think we can take one question. So if somebody is interested in asking a question, please just approach the mic in the center or come up to me. Whoever gets there first gets the question.
I'll be around also, so.
Have we got a questioner here? Wait.
Okay.
No questions. Okay.
Statement in C and in many languages that imitate it is just a way of executing some expressions in a certain order. And then you have to have this I variable, and you have to manage it and do all these things, but you're not interested at all in the value of I. You're just using it to indirectly access the thing that you are interested in. And Python is better because it allows you to focus on what you're interested in, right? So Java initially followed the same for statement, but then in 2004 they introduced this one, which they call the enhanced for in the documentation, and everybody calls the for each, right? So this has been available in Java since 2004, and this in Python since 91. Okay, you can iterate over lots of things in Python, not only native objects or built-in objects, but also arbitrary things like, for instance, a Django query set, or anything that you implement using a couple of interfaces that I'm going to show you. Okay, so let me give you a brief example. These are like snapshots from a session using Django, using the Django shell. So what I'm showing here is Django has this debug object called connection, and through it you can actually read a log of the last queries that Django has sent to the database. Okay, and just to be short, I just assigned the connection queries object to the queue variable, and you can see that it's empty. But then what I do, I import a model from a model file, and then when I do this, which is trying to build a query set with this would fetch all the objects of the municipal model, which represents municipalities in Brazil, and there are 6,500 of them. But I only want to have the five first ones displayed. Again, thank you all for being here. I just want to let you know that in Brazil, where I live, we're going to have a couple of excellent conferences co-located in October. The 9th edition of the Brazilian Python Conference, and the Worldwide Clone Conference will be held in Brazil. It's the first time that it goes across the equator, so we are very proud to have been selected to host that conference as well. And after those conferences, we're going to have an excellent sprint in João Pessoa. It's called the Caipirinha Sprint. It's already a tradition, and please check it out. And I will hope to see many of you there. So let's start. One of the things that really calls one's attention when you start studying Python is how elegant the for loop is, right? And why is it so much better than that one? Mainly because in that one, there's no abstraction for iteration. You're just actually, this is the for state.
Check. Cool. Just before we get started, I did hear some cell phones or tablets or something like that making some noises in the audience just before. If you could please make sure that your noise-making devices are switched off before the talks start, that will save us a lot of embarrassment during the sessions and save us from any interruptions. So please mute your devices if you have any that are currently not muted. And do check them because you probably have forgotten. So you're ready? AV people, you ready? Fantastic. Okay, so it's the start of the last block of talks here at PyCon 2013. Who here is slightly disappointed by that? So am I. But the good news is that we have 3 fantastic talks to finish off the day. Starting off with Luciano Ramalho, who is going to be presenting iterators and generators the Python way. Please make him welcome.
Trying to fix something with the audio right now.
Okay.
But before you start, give us a sign and just wait for a little wave forward.
Oh, always. Right, I'll always signal to you before. Cool.